Okay, in this video we solve, this is 7.1 practice. We're going to solve for angle measures of polygons. So the basic theorem or formula that we're going to use on this is the number of sides, take away 2 times 180 equals polygon sums, where n is the number of sides. If we have to have a regular polygon, and we have a little bit of a different formula, n minus 2 times 180, which is the total number of degrees, divided by the number of equal angles, which is equal to the number of sides, gives us what each angle in a regular polygon measures. So here's the formula we might use. Here's the formula we most likely will use. And the other formula is the sum of exterior angles equals 360, one at each vertex. So we may have a chance to talk about those. So let's see what we got. So for number 1, we have a 1, 2, 3, 4-sided figure. So 4 take away 2 times 180 is 2 times 180, which is 360. So these are going to add up to 360. Add the x's in like terms. We get 12 and 9 is 21, and another 6 is 27, and another 8 is 35. So we have 35 x's. Looking at the numbers, we've got a 6 and a 3 and a 1, which is a plus 10, is equal to 360. Take away 10 from both sides. 35 x's is 350. Divide by 35, x equals 10. Now if x equals 10, they want the measure of each angle. 9 times 10 plus 3 is 93. 12 times 10 is 120, plus 6 is 126. 6 times 10 is 60. And 8 times 10 plus 1 is 81. And all together, these will add to 360 degrees. Or, yeah, add to 360 degrees. Okay, let's look at number 2. So what I need to do over here for this part is make some room. I'm going to erase the regular polygon angle formula thing here. And probably also the exterior angle theorem stuff, give us some room. Okay, so let's see what we have. So we've got a pentagon. 1, 2, 3, 4, 5 sides. So 5 take away 2 times 180 is 3 times 180, which is 540. So these all need to sum up to 540. See, we have x's, 7, 15, 22, 29, 35 x's. Looking at the numbers, we have a 3 and a 7 makes a 10, and a 5 makes a 15. So 35x plus 15 equals 540. Take away 15 from both sides. 35x's is going to be 525. And divide both sides by 35. So we have 525 over 35. If we take 5s out, we have 105 over 7. And 7 times 15 makes 105. So x is going to be 15. Now if x is 15, 7 times 15 is 105, and 3 makes 108. 8 times 15 is 120. 7 times 15 is 105 plus 7 makes 112. 7 times 15 is 105 plus 5 makes 110. And 6 times 15 is 90. And again, all together, these should add up to 540 degrees. Let's look at the next ones. Here we have what looks like a parallelogram. In fact, this is a parallelogram. We see these opposite angles are congruent, even though we haven't really talked about parallelogram properties yet. But we have a four-sided figure. 4 take away 2 is 2. 2 times 180 is 360. These degrees need to add up to 360. We have 12, 13, 14, 15, 16, 17, 18 x's equals 360. Divide by 18. X is going to be 20. 3 times 20 is 60. 6 times 20 is 120. 3 times 20 is 60. And 6 times 20 is 120. And these, again, add up to 360 degrees. 1, 2, 3, 4, we have a pentagon here. So we saw in the previous problem that a pentagon has 540 degrees, interior degrees. So let's combine like terms. 10, 21, 31, 41, 45, 53 x's. And with the numbers, we have 7 and 3 makes 10. 53x plus 10 equals 540. Take away 10 from both sides. 53 x's is 530. Divide by 53. X is going to be 10, which makes angle Q 100. Makes angle R 110 plus 7, 117. Angle S is going to be 103. Angle T is going to be 140, and angle U is going to be 80. And altogether, these will add up to 540 degrees. So look at our B problem here. So let's see, it's talking about the honeycomb. Its regular hexagonal shape is one of only 3 polygons that fit together to fill a plane. Triangle, square, hexagon. Hexagon's the most efficient use. Find the interior angle of the honeycomb. So they're talking about a regular hexagon. Regular hexagonal shape. So if I draw a regular hexagon, doesn't look regular, but I'm going to make it regular by marking it so. It means that each one of these angles is going to be congruent. And we have one angle for each vertex, one vertex for each side. So 6 sides, 6 vertices, and each angle is congruent because we have a regular figure. So n minus 2 times 180 is the number of degrees in the hexagon. 4 times 180, 6 take away 2 is 4, makes 720. So we have 6 equal angles that need to make 720. If we divide by 6, each one of those angles is going to be 120 degrees. So the interior of the angle of the honeycomb is 120 degrees, one at each vertex. Okay, let's look at the next problem. The measure of an interior angle of a hexagon is given, and find the number of sides. So here we have to kind of work backwards a little bit. So our formula is going to be of a regular hexagon. So here's our formula, n minus 2 times 180 divided by n equals the degree of the regular angle. So for this one, we have it equals 135. We have to find out what n is. Multiply both sides by n. and also multiply the numerator times 180, distribute. We have 180 n minus 360 for this numerator here, and then we're going to multiply both sides by n equals 135 n. So distributed in the numerator and multiplied n by both sides to move it to the other side. I'm going to take 180 away from 180 n away from both sides, so we're left with negative 360 is equal to 180 minus 130, or 135 minus 180, which is going to be a negative 45 degrees, negative 45 rather, n is equal to 360. And if we divide both sides by negative 45, we get 8. So this must have been an octagon, regular octagon, to have 8 sides. Okay, same idea for number 7. So we're starting with n minus 2 times 180 over n. And when we calculated everything with the right n, this is going to come out to be 60 degrees. So distribute the numerator. 180 times n is 180n, minus 2 times 180 is 360, and that's going to be equal to, multiply n by both sides, to 60n. Take away 180n from both sides, we have negative 360 equals negative 120n. Divide both sides by negative 120. We get n equals 3. So this is a regular triangle, which we call a equal angular triangle. Equal angular triangle. And we talk about, we've seen before, equal angular triangles, 360-degree angles works out. Okay, let's look at this one. We get 165 degrees. N minus 2 times 180 over n comes out to be 165. Multiply both sides by n. 165n equals, distribute the numerator, 180n minus 360. It's equal to 165n. This time I'm going to take 165 away from both sides. So I get 15n minus 360 equals 0. Add 360 to both sides. 15n equals, I'm just doing that to get rid of them, keep them having to deal with negatives. 15 n's is 360. Divide both sides by 15. N is going to be 20. It's going to be 300. And it's going to be 24. So this is a 24-sided regular polygon. It's a 24gon. A regular. Regular means all the angles are congruent. So a regular 24gon. They're going to equal 360. And we have 5, 8, 12 x's. And number-wise, we have a 96 and a 1 makes a 97, and an 8 makes 105, and 15 makes 120. So 12x plus 120 equals 360. Take away 120 from both sides. 12 x's is 240. Divide both sides by 12. X is going to be 20. So if x is 20, we have a 101-degree angle there. We have a 68-degree angle there. We have a 95-degree angle there. And we got our 96-degree angle there. All together, these should add up to 360 degrees. Okay, let's look at number 10. Number 10, exterior angles, one at each vertex. Check out, make sure we got the right pattern here. These are all going to add up to 360 degrees. And we need to combine like terms, starting with this one: 5, 9, 13, 17, 19 x's, plus, looking at the numbers, a 3 and a 14 is a 17, and a 1 makes an 18, plus 18 makes 360. Take away 18 from both sides. 19 x's is 342. Divide both sides by 19. We have 342 divided by 19. Let's see, if 9 times 8 is a 72. So maybe this is an 18. Let's see what 18 times 19 is. I'm going for like the 2 here. So we got 72, carry the 7, 9, 16. Got an 8 and a 1. 7, 4. Carry the 1, 347. Or 342 rather. That is 342. So this does go 18 times. So x is 18 for that one. And if we multiplied it through, 4 times 18 is 72, 72. 5 times 18 is 90 plus 3, 93. 36 and 1 is 37. And 4 times 18 is 72 plus 14 makes 86. Altogether, these should add up to 360. Okay, here we have a hexagon, but exterior angles, one at each vertex. It's going to counterclockwise direction. These all need to add up to 360 degrees. So combining like terms, going for the x's, we've got 1, 2, 3, 4, 5, 6, 5 x's. 5 x's. Looking at the numbers, we've got an 18, 24, 25, 35, 45, 47, 94, 154, 155, 29, 69, 73, 69, 76, 136, 137, 147, 155. Yeah, it does add up to 155. So we're going to take 155 away from both sides. 5 x's is 305. Divide both sides by 5. X equals 305 over 5, which is going to be 61. So x is 61, and that means we have a 66. We've got a 122 plus 1 is 123. We got a 61 and 22, which is an 83. We have a 47, we have a 61, and we have a, which is really the same thing as x, and we have a 61 and 18, which is a 79. So altogether, these angles should all add up to 360 degrees. Let's move on. Find the angle measurement of each exterior angle of each regular hexagon. So we're talking about a square. So if I sketch a square here, label the sides as all congruent. Square, these are all 90-degree angles. And to talk about exterior angles, I extend the sides in a pattern like this. Talk about this angle, this angle, this angle, and this angle. We can see that, like if we pull up on this part here, basically we got the inside part of the square, which is a right angle, and a linear pair means that that exterior angle must be right. So we have 1, 2, 3, 4 exterior angles. Each one is 90 degrees. Now using the formula, n minus 2 times 180 over n. We have a regular 4-sided quadrilateral, which is a square. So 4 take away 2 is 2 times 180, and n is 4, and 360, which is 2 times 180 divided by 4, gives us 90. So the formula also gives us 90 degrees. Now if we have a decagon, we got 10 sides. Be easier just use the formula on this one. N is 10. We have n minus 2 times 180 divided by n. N take away 2 is 8 times 180 divided by 10, which gives us 8 times 18. If I take the 10 out of that, that's going to be 80, and another 64 gives us 144. So each exterior angle in a decagon is going to be 144 degrees.